All right, so two more examples to show you involving or how to solve trig equations. Our strategies are still the same. There's just a couple of variations here. So in this case, let's actually solve just in radians, and then we'll solve for all angles too, because I think degrees tends to be more intuitive for people. So we'll do kind of the more challenging part. So the first thing is we need to start by taking the inverse. We can't do that though because there's no inverse of secant on the calculator. So easiest way to solve this is let's just change this problem into a cosine problem. So remember that cosine and secant are related as inverses. What if cosine is 5 over 6, secant would be 6 over 5. So let's change this into cosine instead of secant, and we'll just flip those around. So now cosine is equal to 3 over 2 root 3. Okay, now how do we cancel out the cosine? We can do that by taking the inverse cosine. And this is going to give us an angle, and that's what theta will be. Okay, the other thing to keep in mind is cosine is positive in two places, because that's what this says right here. Use all students take calculus. So our answer is going to be positive this. That's going to happen in the first and fourth quadrants. So we need to know what this angle is in both of those quadrants. So we'll do inverse cosine of 3 divided by 2 root 3. You have to be careful how you enter this in the calculator too. So I'm going to show you how to do that. So inverse cosine of 3 divided by, and then I need to put this in parentheses, right? Because it's 2 root 3. I don't want to just divide by 2. I want to divide by 2 times root 3. So in order to do that, you need to make sure the parentheses are. I always tell people when in doubt, use parentheses. So close that parentheses, and then we have to close the other one also. Okay, and we will get 30 degrees as our answer. Okay, so that's one of those familiar angles, the 30, 45, 60 type angles. Okay, so this is 30 degrees. This is 30 right here, so that's our first answer. And our other answer is going to be all the way around except for that last 30 reference angle, and that would be 330. Okay, so we've taken care of this part. Let's get those in radians. So if we change them to radians, 30 is pi over 6, 330 is 11 pi over 6. Okay, and then how do we do this? How do we get it for all angles? Well, let's think about the pattern here. So for the 30-degree one, it's going to be 30 plus however many rotations of 360 that we do. And that's how we say this. 360 times n is the number of rotations that we choose to do. And this one will be 330 plus 360n. And that is taking care of all solutions for all angles. Alright, let's try the sine one. This is slightly different because now we're going to get not a nice even number like 30 degrees this time. But the process will still be the same. So we will take the inverse sine of this and the inverse sine of this right here, keeping in mind that sine is negative right here, and sine happens to be negative in that quadrant and in that quadrant. So we want to know what angle, and this is going to give us a reference angle. So inverse sine of negative 0.24. Okay, and this should be a negative angle because the domain here is between 90 and negative 90. So we get negative 13, let's round that to negative 13.9. Okay, so negative 13.9, that means this reference angle right here is 13.9, which means the reference angle in this quadrant is also going to be 13.9. Okay, so we need to find two angles. We need to find this red one right here, and we also need to find this blue one right here, which goes all the way around except for that. So the blue one is going to be 360 except for that last 13.9, and that will be 346.1. So that's one measure for theta, and the other one for theta is going to be, this red one will be 180 plus that 13.9 because you're going slightly past 180. That turns out to be 193.9 degrees. Okay, then we can do the same thing. We can add 360n and we can add 360n because that will take care of the multiple rotations. So that takes care of all angles. And then let's change these into radians. So this is going to be 346.1 times pi over 180. Again, the reason 180 is going on the bottom is because degrees are what we're trying to cancel out. So if we were trying to cancel out radians, if this were something with pi, or if that were a number, then you'd swap the pi and the 180. So let's solve each of these in radians. So 346.1. And actually, even before we do that, let's think about the answer. 346 is almost all the way around the circle, so that's almost 2 pi. And 2 times pi, or 2 times 3.14, is 6.28. So we know that if we do this correctly, our answer should be approximately pretty close to 6.28. So let's verify if that is what takes place. So 346.1 times second, that kind of caret symbol right there, and then we'll divide by 180. And should be close to 6.28, and it is. So 6.04, pretty close. The other one was 193.9, and we'll do the same. We'll multiply it times pi over 180. And then at the end, to show all solutions, instead of adding multiples of 360, instead of plus 360n, you can just add plus 2 pi n. So those are our two answers. 3.38, that's slightly more than pi because we're slightly more than 180 degrees. So that's how we would write. We would say 6.04 plus 2 pi times n. There's one. That's this answer right here. And the other one was 3.38 plus 2 pi n. And that's the radian version of that. So that's how we solve inverse trig functions.